So our next set of exercises, we're supposed to find the measure of each numbered angle in the figure and name the theorem that justifies your work. And so here are the answers. And so you can go ahead and check this with the work that you've done independently. And then I'm going to go ahead and move on down to the proof on number 7. Okay. So we have our proofs on 7 and 8. So here's 7. Here's our figure for 7. And I'm not sure if there's anything I want to say here, except we apply our angle addition postulates, right, to say that this big angle is equal to one of the angles plus the other angle. And then we also apply it here as well to say that this big angle is equal to the sum of its parts, right, the two smaller angles. And then from there we use substitution to get to the proof. Okay, and then for this one, yeah, I don't think I have to say much about this short little one here. And this number 9, also a very short and easy proof, right? Angle 1 and angle 2 are vertical angles, and the vertical angles theorem states that they're congruent, right? So the shortest proof we have encountered thus far, but they do get more complicated. So we have number 10 here, and what did we do for number 10? Well, it says here that DB is the bisector of angle ADC, so we could say angle 1 is congruent with angle 2. We could also use the vertical angles theorem to say that angle 1 is congruent with angle 3, right? But first, before we do that, we need to say that angle 1 and angle 3 are vertical angles. Okay. And then from there, we're going to use the transitive properties, so use some algebraic properties to get to the proof. All right. And then here for number 14, what do we start with? That the entire angle is a 90-degree angle, and we need to prove that ABD and CBD are complementary, right? And so how do we prove they're complementary? We need to use the complementary angles theorem. And what is the complementary angles theorem? It states that if two non-common sides form a right angle, then the angles are complementary angles. Okay. And so what we need to do to prove that these two angles are complementary is we need to prove that the measure of angle ABD plus the measure of angle CBD is equal to 90 degrees, right? Step 4. That's how we got to get there. So we start by saying that ABC is equal to, measure of ABC is equal to 90 degrees because of the definition of right angles. And then we use the angles addition postulate to say that the entire angle is equal to the sum of its parts. Then we do substitution to say that the sum of its parts is equal to 90 degrees. And then that gets us to our proof. Right? Over here, this one, we're supposed to prove, we have these angles, and we're supposed to prove that angle 4 and angle 6 are supplementary, not complementary. So how do we prove that angle 4 and angle 6 are supplementary? We need to prove that angle 4 and angle 6 added together are equal to 180 degrees. All right, so how do we do that? Well, we start with the given. Angle 5 is congruent with angle 6. We go to measures. Then we say angle 5 and angle 4 are supplementary by the definition of linear pairs and given the figure, right? From there, we could say that angle 5 plus angle 4 is equal to 180 degrees from the definition of supplementary angles. Use substitution. Now we're using our algebraic properties to say that angle 6 and angle 4's measure are equal to 180 degrees using substitution. And that gets us to our proof. That lets us say that angle 4 and angle 6 are supplementary by the definition of supplementary angles. And I think that is it.